Hello everyone, this is Samir Ravindra Panda, a BE Electronics and Computer Science final year student from Pillai HOC College of Engineering and Technology. I would thank EMERTXE for providing me an internship, and I would also thank my project guide Jay Lakshmi ma'am. Our project topic is IoT based home automation solution. Let us move to our slide presentation part that would explain what we learn in our internship. Initially, we start with C programming. In C programming, we learn various keywords, basic data types such as int, char, float, double, void operators, and also learn about conditional constructs and looping concepts. We learn about pointer functions, built-in and user-defined functions, and also learn about storage classes, preprocessor derivatives, and header files. After learning C programming, we learn about C++ programming. In C++ programming, we learn OOP concepts and various other things. We learn about IoT introduction, definition, and its architecture. Along with it, we learn about embedded system definition and component of embedded system. And in embedded system, various peripherals are used. The peripherals such as LED, Arduino Uno, CLCD, ADC, LDR sensor, temperature system, serial tank. So what is actually a IoT? IoT is a network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment. These IoT devices are about 7 billion connected today. And according to expert, in 2025 it will grow to 22 billion. Because of this low cost computing, the cloud, big data analytics, and mobile technologies, physical thing can share and collect data with minimum human interventions. In this way, the hyper connected world digital system can record, monitor, and adjust each interaction between connected things. So what is embedded system? Embedded system is the combination of hardware and software which is intended to do a specific task. The embedded system is consists of three parts: software, firmware, and hardware. Unlike computer, embedded system can only perform but specific task. Embedded system peripherals are such as serial communications interfaces, synchronous serial communication interface, universal serial bus, multimedia cards, etc. What are our project requirement? Our project requirement are garden lights, temperature control system, water tank control. Garden lights will be used to will be based on the LDR sensor. As the sunlight intensity increases, the brightness of our LED will decrease, and in vice versa, if the sunlight intensity increases, the brightness will decrease. Temperature control system will be used for heater and cooler on and off. The temperature control system will measure the temperatures of our surrounding. Water tank control will be used to control the inlet and outlet of our tank. So what are our hardware requirement? Our project hardware requirements are Arduino Uno, Ethernet shield, PCF8574, temperature sensor, LCD, LDR sensor, LED. And what are our software requirements are Arduino IDE, Pixel Lab, Null Emulator, Blynk IoT app. Arduino IDE is used for coding purpose. Pixel Lab is for all simulation of peripherals, and the Arduino Null Emulator will be used for creating a virtual port such as COM1, COM2, or COM3, COM4, COM6, COM7. Blynk IoT app will be used for our mobile device so that we can control the all IoT devices. Arduino Uno is based on Atmega 328P microcontroller. Arduino Uno consists of 6 analog pin input, 14 digital pins, a USB connector, a power jack, and an ICSP header. It, the Arduino Uno is easy to use as compared to other board and mega boards. And Arduino Uno can be programmed using Arduino IDE. This is the picture of Arduino Uno. So Ethernet shield. We are using Ethernet shield to connect our Arduino our IoT devices to internet, and from there it will be connected to our mobile. This is all based on cloud technology. PCF 8574. We are using PCF 8574 for general purpose remote IO expansion for most microcontroller families. Temperature sensor. We are using temperature sensor for measuring the temperature of our room. The temperature sensor consists of 3 pin, one for 4 to 20 volt, one for out, one for ground. LCD. We are using LCD to display the temperature reading and also the volume of our tank. LDR sensor. We are using LDR sensor to measure the sunlight intensity. As we know that the brightness of LED changes based on the sunlight intensity. It is inversely proportional to the, such as if the brightness of environment increases, the LED brightness decreases. What is the abstract of our project? Our project abstract is home automation using Arduino and Blynk application. It is used for controlling garden light based on whether it is day or night. We are using fan and heater for cold and hot in our room, and we are also using water tank controlling system for controlling inlet and outlet valve. So this is our functional requirement. In our functional requirement, we required Arduino IoT devices and Blynk app. Arduino Uno is connected to LDR sensor and light. Based on LDR sensor, LED brightness changes. LDR sensor and light is inversely proportional to each other. Their brightness is inversely proportional to each other. This is temperature control system. In temperature system is connected to Arduino Uno, and Arduino Uno is connected to Blynk IoT app. And Blynk IoT app is connected to Arduino Uno, and Arduino Uno is connected to CLCD and temperature system. So that similarly, water tank system also works. The CLCD is used to display the water tank level and temperature level, and Blynk IoT app also displays all these things. We are using Blynk IoT app also to control this water tank and temperature system. So our what a Blynk application will contain. Our user interface of Blynk application will contain budget, button widgets and gauge widgets. Button widgets to control heater, cooler, inlet valve and outlet valve. Gauge widget will be used to control the temperature or volume, to display the temperature or volume of tank. So what is threshold? We have put a threshold in temperature system such that if the heater is on and the temperature goes beyond 35 degrees Celsius, then the heater will automatically switch off or turn off. This is the LED system which we are using for our project, and we can see that our LED system displays the temperature and volume, and also displays weather which is on and off. Now our project consists of four parts. So you can see that Arduino IDE, tank, spare parts, and Arduino Uno. So we are conclude that our using Blynk IoT app and Pixel Lab, our home simulation can be done, where we control LED temperature system, serial tank, which resembles light, heater, cooler, and water tank in real time. And CLCD displays used to display uh, temperature and volume. And similarly, Blynk IoT app also displays all these things. And gauge widget used to display temperature and volume of water. Now we will go towards project coding part, and this coding will be done in Arduino IDE. project coding part, we first start with code involves setting up Blynk template ID, template name, and authentication token. These identifiers are crucial because they enable the Arduino to connect to the Blynk server. The Blynk platform is an IoT solution that allows users to monitor and control their device remotely using a mobile app. By defining these IDs and token, the Arduino becomes a client that can send and receive data to and from the Blynk cloud, ensuring that the user can interact with the home automation system from anywhere in the world. So how we get the template ID and authorization token? We get the template ID and authorization token from this website blink.console, from where you can get. And after that, we include several libraries in the code, each serving a specific purpose. The SPI and Ethernet libraries are critical for establishing network communication, which is essential for the Blynk integration. The wire and liquid crystal I2C libraries handle the LCD display communication. The LCD is connected via I2C, a protocol that allows for communication over two wires, making the setup less complex and more efficient. Additionally, custom libraries like temperature system.h, LDR.h, and serial tank.h, temperature system.h are also used. These modular libraries help in organizing the code better, making it easier to maintain and extend. And uh, after that we have initialized several boolean variables to keep track of whether each component is on or off. These variables are essential for controlling the system's behavior, ensuring that each component only operates when it should. The tank volume variable stores the current volume of the water tank, which is continuously monitored to manage the water level. The blink right function for the cooler or heater are where the interaction between the user and the system takes place. When the user toggles the cooler or heater via the Blynk app, the system reads the state on or off from the app. If the cooler is turned on, the system sets the cooler to true and activates the cooler by calling the cooler control on function. It also updates the LCD display to show the cooler is on, giving immediate feedback to the user. Similarly, if the user turns off the cooler, the system deactivates it and updates the display to cooler off. The heater control work in the same way. As you can see the heater code, ensuring the user always know the current state of their appliances. After that, we set similar logic applies to the water tank inlet and outlet valves. The valves control the flow of water into and out of the tank. When the user turn on the inlet valve through the Blynk app, the system sets the inlet variable to true, activates the valve by calling enable inlet. The updates the LCD to show it's on. This ensure the user knows the water is flowing into the tank. Conversely, turning off the inlet valve deactivates it and updates the LCD to inflow. The outlet valve control operates similarly, managing the water flow out of the tank. After that, the function update temperature reading is responsible for reading the current temperature and sending the data to the Blynk app via Blynk virtual write function. This ensures the user can see the real-time temperature on their mobile device and allowing them to make informed decision about their home environment. After that, the function handle temp continuously check the temperature to ensure it stays within a safe range. If the temperature exceeds 35 degrees Celsius, uh, exceeds 35 degrees Celsius and the heater is on, that system automatically turn off the heater to prevent overheating, which could be dangerous. This is a critical safety feature that adds intelligence to the system, reducing the risk of fire or damage due to excessive heat. The system also updates the Blynk app and the LCD display to reflect this change, keeping the user informed of the system actions. And after that, we go on to the water tank management. In water tank management, the system continuously monitors the water tank volume using the handle tank function. If the water level drops below a certain threshold, in this case 2000 units, the system automatically opens the inlet valve to refill the tank, ensuring that there is always an adequate water supply. This prevents situation where the tank might run dry, which could be problematic for household water needs. Once the tank reaches 3000 units, the system closes the inlet valve to prevent overflow, thus protecting the home from potential water damage. These operations are displayed on the LCD, so the user is always aware of the current water level and the status of water. After that, we go on to the main loop execution. This function is the core of the program, where the system continuously performs the task. It first manages the brightness of garden light using data from LDR, then it reads the current temperature and updates the LCD display. The water tank volume is also measured and displayed. And here are some functions which are run in this loop. After that, we go on to the ldr.cpp and ldr.h. In ldr.h, this is a preprocessor directive that stands for if not defined. It used to check whether ldr.h has already been defined in the file or another included file. It is hasn't the code between the directives and the corresponding endif is included in the complication process. This prevents multiple inclusions of the same header file, which could also complicated error. In this way, we similarly define few uh, variables in this. Now we go to the main.h. Here we define the buttons variable name and define on and off state. After that, we go to the serial tank.cpp. And in serial tank.cpp, we define various serial tank addresses and also detail about its volume when, and it also tells what happens in inlet enable and disable, similarly for outlet disable. This is the defined variables of serial tank. Now we go to the temperature system.cpp. In temperature system.cpp, we defines what this temperature system works when this cooler and heater works. This is explained using two loop, void cooler control and void heater control. These are some variables defined for temperature system.h. And now we will go towards simulation part. In project automation part, first I have selected COM1 and COM2 as local bridge. After selecting this, I have loaded the hex file which I have created from Arduino IDE. After I have loaded hex file like this, after loading hex file, I have taken spare parts as Ethernet shield, temperature system, LDR system, CLCD display, LED. And after taking this, I have configured Arduino. This is Arduino as COM1, and for um, remote serial tank, I have selected it as COM2. After doing this, and I have also configured spare parts port details, as you can see from the display. And I have to also take screen mirroring of my smartphone to automate our project. These are the buttons which I have created. The four buttons are cooler button, heater button, inlet valve, outlet valve, and this is temperature gauge. In our project, um, this is Ethernet shield. As Arduino cannot be connected to the internet directly, so we are taking Arduino no, Ethernet shield. Mm, and you can see that heater is off. It is showing on the display. When I click cooler as on, you can see that cooler get switched on. When cooler switch on, the temperature is showing 27.34 degrees Celsius. And when I switch off cooler and switch on heater, you can see that heater gets switched on, and this temperature will also going to rise. And as you can see, the temperature rise as 27.83 degrees Celsius, now 28.32 degrees Celsius, because of heater. This rise in temperature can also be seen in um, temperature gauge. By that time we are going to see that how a LDR system work. In LDR system, when brightness level is high, uh, LED gets switch off. When this brightness level increases, LED switch ons. Brightness level decreases, LED switch ons. And for our heater temperature, when this heater temperature will go to 35 degrees Celsius, then heater will automatically get switch off. And for our water inlet part, but for water inlet and outlet part, we will use these two buttons, inlet valve and outlet valve. As you can see, when temperature crosses 35 degrees Celsius, heater get automatically switch off. Now we will see water inlet and outlet part. When water inlet button is switch on, then tank goes on increasing it water volume. When water outlet valve is switch on, then tank's water get go decreasing. And this reading can also be seen from our LCD display. And in this way our project get automate